classify materials a little bit differently. There's lots of ways that we can break things up and break them down. So first type of grouping we want to talk about are atomic elements. So these are elements whose particles are single atoms. So you can think about these as like magnesium, calcium. You could think about these as sodium. Any of those are going to be single elements, atomic elements. Those are kind of the ones you think about. When you think of just an element, you just think about a guy by himself. Then we have what we call molecular elements. These are the new ones. These are elements whose particles are multi-atom molecules. And we talked about these when we talked about the halogens. Okay? So for example, these are what we call diatomics. We talked about these when we talked about the halogens. I said we would talk about them in more depth. But then you can also have ones that are more than diatomics, than just one. They could have 6 or 8 or whatever. But mainly when we're talking about these, we're going to talk about the diatomics. And I'll talk about more of those on the next slide. So those are when it's just one element. So I can give you some examples here. This is like Cl2, F2, Br2. So if you notice, this is just an element. This is just an element, but in nature, you don't find Cl just by itself. It's going to be Cl2. So that's why it's a molecular element, because you have more than one. You have multi-molecules. This is an atomic element because you have a single atom. Now we're going to talk about what if I have more than one different type of element together. So the first one are molecular compounds. These are compounds whose particles are molecules made of only nonmetals. So these are going to use covalent bonds. These are the ones that we're going to be talking about now. So now when we start talking about naming and this section of naming, we're moving into the molecular compounds. So an example of this would be water. Because water is hydrogen is a nonmetal, oxygen is a nonmetal, so they're all nonmetals, and it's more than one element, so it makes it a molecular compound. Okay? So this is our second group for this chapter that we haven't covered yet. We're starting to cover it now. And then the last one we've already done, ionic compounds. These are the ones that we just finished. These are compounds whose particles are cations and anions. Okay? So an example there is they're going to use ionic bonds. This would be like NaCl. Okay? Because you've got a metal and a nonmetal, but specifically this is the cation, this is the anion. Okay? So remember, ionic compounds, you have a cation and an anion. The cation could be a metal invariant, metal variant, or a polyatomic. The anion could be a nonmetal, or it could be a polyatomic. So far we've talked about these. So far we've talked about these. And now we want to talk about these two. These are kind of the new ones. But notice that these are elements, these are compounds because there's more than one element. These are one element. These are ionic, molecular, and then atomic. All right, so let's talk about these two in a little bit more depth. So first let's talk about molecular elements, and then the rest of this section we'll talk about molecular compounds. So what are molecular elements? So certain elements are going to occur in nature as diatomics. These are your diatomics. Think of this as the rule of sevens. So there are 7 of them. And if you look on the periodic table, they kind of make a 7. So if you notice, here's this part, makes a 7. And then hydrogen's kind of floating over here is like the long end of the 7. So these 7, if I were to say like, oh, nitrogen reacted with something. If nitrogen's doing the reaction, you have to know it's N2 and not N. So you have to know which ones form diatomics. Okay? So this is my rule of 7. Certain elements in nature, you're not going to find it just by itself. It's not going to be just hydrogen by itself. It's always going to be H2. So here you can just kind of see it on the periodic table that these elements exist as diatomics. Now I kind of mentioned that some of them exist in more than just that. So for example, sulfur could be S6. So sulfur can be a number that's more than 2. And phosphorus can do that, but you don't need to worry about those. They're still technically molecular elements because it's one element but multiple atoms. But what you need to know is you need to know my 7 here, my diatomic elements, right? All right, so now that we've introduced and talked about my molecular elements, now let's talk about the molecular compounds in a little more depth. So now we want to talk about some properties and characteristics of molecular compounds, and that'll be the topic for the next lecture.